Hello, children of the West. It's time right now to learn how to derive the Pythagorean identities. Now, just as a reminder, at the very start of the PowerPoint, this unit, I said that you can use these on your exam. And that's correct. However, you're also going to have to learn or teach me or show me that you know how to derive the Pythagorean identities. So those Pythagorean identities are right here. We're going to start with the first one right here. This is the one that you really should have memorized. Sine squared theta plus cosine squared theta equals 1. This is so important. We see it in calc all the time. You'll see it in this unit all the time. So put that one to memory, even though you don't need to for your test, but we'll need to know it here. We're going to prove the first Pythagorean identity by looking at the unit circle. You can see here that this line, this blue one, is 1 because remember, a unit circle has a radius of 1. And you should also note that this distance right here is x because that's an x distance. And this distance right here is y, that's that upper distance. All right, I'm going to go ahead and I'm going to solve for sine of theta, which we should know is opposite over hypotenuse. In this case, that's y over 1. Well, what's y divided by 1? It's just y. So this is sine theta equals y. All right, now let's solve for cosine theta. That's cosine theta equals adjacent over hypotenuse. And in this case, my adjacent to this is going to be x over my 1 right here. So cosine theta is going to be adjacent, which is x, over my hypotenuse, which is 1. And if you're having a hard time with that, just know that we've got our opposite, our adjacent, and our hypotenuse. And we're just setting up trig equations and solving for them. And notice here that I can simplify it and just say cosine of theta is equal to x. So what are the two important things here? Well, that's going to be sine theta equals y and cosine theta equals x. So I'm just going to rewrite those over here. I've got y equals sine theta, and I've got x equals cosine theta. All right. So then here, I'm going to go ahead and write something different. I'm going to use the Pythagorean theorem, and I'm going to call this A, I'm going to call this B, and I'm going to call this one C. We know that this is a right triangle, so I can do Pythagorean theorem, and I can state that A squared plus B squared equals C squared. Well, that's x squared plus y squared equals 1 squared. Well, what's my x in this case? It's cosine, and I'm doing cosine theta times cosine theta, which we should now know that that's cosine squared theta. Okay, then plus my y squared is going to be sine theta times sine theta, which is sine squared theta. And of course, 1 squared is simply just 1. So I'm going to put that there. I'm just going to rearrange this just because out of tradition we put sine first, so it's going to be sine squared theta plus cosine squared theta equals 1. All right, moving on. Now that we have our first Pythagorean identity done, I want to try to get this second Pythagorean identity. And the goal for this is to realize that we're trying to get the right side to be secant squared theta. Well, remember here that secant theta is 1 over cosine theta. So if I were to divide this by cosine squared theta, that would give me what I need over on the right side because I need a secant squared theta, right? See how 1 over cosine theta, and I've got 1 over cosine squared theta, so this would give me secant squared. Well, I don't have the ability to just divide by anything I want. If I want to divide by something, I have to do it on all sides. So I'd have to divide by cosine squared theta here, and I'd have to divide by cosine squared theta here. Now, what is sine over cosine? Well, going over here, sine over cosine is tan. But here I've got sine squared over cosine squared, and so that's going to give me a tangent squared theta. Oops, I don't need an equal sign. All right, so that just simplified that. Now let's simplify cosine squared over cosine squared. Well, that's just going to be simply 1. And we already reviewed this, but 1 over cosine is secant. So 1 over cosine squared is going to be a secant squared theta. Okay, so that does match. If you look over here, we've got a perfect match of tangent squared theta plus 1 equals secant squared theta. All right, let's go ahead and let's see if we can prove the third identity. And just notice right here we divided by cosine squared theta. So what do you guess we're going to divide this one by? Well, I think kind of the hint here is we've got a 1 right here for the third identity we're proving. And so if I want to get a 1 here, I have to divide by sine squared theta. All right, so what does a sine squared theta over sine squared theta become? That becomes 1. What's a cosine over sine? Well, cosine over sine is cotangent. So here I've got cosine squared over sine squared, so that's going to give me a cotangent squared theta. And what's 1 over sine squared theta? Well, 1 over sine is cosecant, so this is going to give me cosecant squared theta. Now, do we have a match? Let's go ahead and let's look. Does 1 plus cotangent squared theta equal cosecant squared theta match? Why, yes, it does. So that's how we prove our 3 Pythagorean identities. They're going to be extremely useful for our next video. Thanks for watching.